Hello, everyone, and thank you for joining us today for part 2 of our infrastructure webinar series, Answers to Aging Infrastructure Challenges, When to Reline Aging and Failing Culverts and Sewers. Before we start today's presentation, I would like to cover a few housekeeping matters that make sure you have a good experience. We have placed all phones on mute to cut down on background noise and to ensure everyone can hear the presentation. At the conclusion of today's webinar, we will provide information on how to obtain PDH credit for today's presentation. Our webinar today is scheduled to last for 1 hour and will include a question and answer period. If you have a question, please type it in the question box at any time. Today's webinar is hosted by Ryan McCaslin and Andrew Jenkins. Ryan McCaslin is the Drainage Area Manager for the Great Plains and the West for Contech. Ryan has been with Contech for more than 20 years and has experience in manufacturing, construction, and marketing for various civil engineering construction materials. Most recently, Ryan has focused on wastewater, stormwater, and irrigation conveyance and pipeline rehabilitation. Ryan has a bachelor's degree in civil engineering from North Dakota State University. Andrew Jenkins has a bachelor's of science degree in engineering from Missouri University of Science and Technology. He has 24 years of experience in civil, mining, and petroleum engineering industries. For the past 18 years, Andrew has held multiple leadership positions at Contech. Most recently, he was the Director of Plastics Division and Director of Wastewater Management. Andrew has written several professional development articles, presented on behalf of the PVC Association, and has trained thousands of engineers across the country on thermoplastic pipe types. Now I'll turn the presentation over to Ryan to get us started.
Thank you, Jill, and good morning, everybody. Hope everybody's having a great Thursday. Today, I'd just like to have a brief start of reminding everybody who Contech is and what it is we do. Contech is divided into 3 separate divisions. The Structures Division, which covers bridge structures, pedestrian bridges, vehicular bridges, and buried structures. Our Stormwater Solutions Group, which focuses on underground detention and stormwater treatment, and the Pipe Solutions Group, which talks about sanitary sewer, pipeline rehabilitation, and storm sewer. One of the things that we talk about or we hear from our customers is that the earliest that they bring us on, the more value we bring to the project. And that's seen in many different ways, but from the feedback I've gotten, the most valuable way is when we're looking at a project and we could say either yes or sometimes more importantly, no, our product could or could not work in this application. And that's the value that Andrew and I are trying to offer to you today. We'll talk about more of that over the time, but as I get into the presentation, we're going to focus today on pipeline rehabilitation. And really what pipeline rehabilitation is and why it's becoming more and more important today is because of the quote unquote political challenges that you have with, say, traffic disruptions and detours when you're replacing either a structure or a storm sewer, sanitary sewer, or culvert. These days, there's a lot more utilities existing in right-of-ways and around our storm and sanitary sewer products, and it's more easier for us to slipline a project instead of rip and replace. And finally, a lot of applications, especially with pipeline rehabilitation, we're able to save the customer more money as opposed to really just ripping and replacing. If you have seen the past 2 years of where we have talked about pipeline rehabilitation, this agenda won't look new to you, but we're doing it a little bit different this year. The last couple years where we have focused on these 7 critical design considerations, we walked through each one and showed you some case histories. This year, Andrew and I are doing it a little bit differently. We're going to focus on 4 specific case histories and show how the engineer and the contractor went through each of these design and construction considerations. So we're going to dive deeper into specific case histories and show you where and how these design and construction considerations affected each project. The one thing I'll point out is the fourth design and construction consideration, the material and method selection. It's kind of an overlying consideration as you look at each of the other condition assessments, the hydraulics, the structural design. That's really what informs the material and method selection that we're talking about. So that's going to be not a specific slide, but something that is going to be looked at in each situation. After we get done with our four case histories, we're going to go through and reiterate the value that Contech brings and some of the other items that you have at your fingertips. I would be remiss if I didn't talk about the 14 products that we have for pipeline repair, bridge repair, and extensions. Today we're going to focus primarily on drainage structures, so storm sewers and culverts and sanitary sewers. So that's going to limit the products that we're going to talk about. But on this slide you can see, especially from the bridge side, where we can actually reline a bridge, if you will, and we have that capability and that experience. So this is something that is available to you. Just because you're replacing a bridge, Contech can still help. We're going to focus today more so on the drainage side. So diving in first into our case histories. The first one is coming to us from Nebraska, and it's the Candlewood Reservoir Reline project. And this, you can see from the picture, an aerial view, had a reservoir with a principal spillway, and that principal spillway was a 48-inch RCP. If anybody has worked with dams in the past, obviously digging down and replacing infrastructure in that dam, through that dam, can create potential future challenges just because of removing some of that soil and then having to put it back into place. HDR out of Omaha was a design engineer. Sean Bell was the engineer who worked with it primarily, and it was installed in 2020. As we scroll in to give you a better idea of the condition and all the pipe that was in place, what we have in the bottom of the picture here is the inlet structure and a 48-inch RCP going through the majority of the dam, and then as it daylights, that transitions to a concrete flume. I'm trying to show you that here. Actually, as you'll see in some of the pictures and videos we have coming up, that concrete flume was used quite extensively from the installation standpoint. And then a profile view. This was taken from some plan sets that were pretty old, so it's not as clear to you as it could be, but it gives you an idea of the profile and the fact that we're close to 30 feet deep. So not only digging through a dam was a challenge, but the fact that it was 30 foot deep. HDR started off pretty quickly with, hey, can we rehab this without having to dig down? The challenges they were having was leaking at the inlet, which they were able to clog using or stop using separate materials. And then the real challenge that this project was focusing was water infiltration at the joints. So this is a video that I'm going to show to you, and it should be playing now. This is some of the CCTV that we were provided with, and you can see in the RCP there's some spalling in the invert, and as the rover moves forward you see some continued spalling, and it's going to stop at the next joint. This is not the entire CCTV, this is just a section. I think the entire CCTV was half an hour to 45 minutes long. So as this pans up to show the joint, you can see some previous repair methods that the owner had done using ram neck and other types of things to seal the joints to keep water from infiltrating through those joints. And then it's going to pan over to the rest of the area, and you'll be able to see just some of the joint challenges that the owner was having, which was the real reason why they were looking at rehabbing this and stopping that infiltration as it comes in. So as this video resets, you'll get to see some of the misalignment that had started to take place, and they were trying to offset some of that as well. So this, we had some relatively good information from the condition assessment that was taken. So with that, some of the first calculations that HDR did was determine hydraulically what was needed here. Hydraulically speaking, we were told we needed a Manning's End minimum of 0.012 and a minimum diameter of 44 inches, which obviously is not a standard diameter as you have it. So we started looking at 3 different products. The first one is a Duramax SRPE. It had a Manning's End of 0.012, so that checked the box. But the problem was the inside diameter was 41.3 inches. It did not meet the minimum that HDR determined was required. A2000, Manning's End of 0.009. So we exceeded that there with that product, but the largest that product goes is 36 inch. So we weren't able to make that work. Ultraflow, which you'll see some pictures of it coming up in the next few slides, it is a smooth steel reline product or direct bury product. And the benefit of this is because of the way it's manufactured, we can manufacture Ultraflow to the nearest inch. So we're not limited to, say, the nominal diameters, 36 inch, 42 inch, and 48 inch, like the other 2 products that we were considering are. But instead, we were able to make it at 44 inches ID. It had a Manning's End of 0.012, and then we started talking about lifespan. Obviously, the first 2, the steel reinforced polyethylene and the A2000, those are polyethylene and PVC products, respectively. But with steel being the base metal for the Ultraflow, there was a concern about longevity. And with the different coatings that we were able to provide, we could provide between 75 or even greater than 100 years. And once we were able to show that, then our product was selected, and we started the design process down to steel Ultraflow. From a structural consideration, as far as Ultraflow is concerned and metal pipe as a whole, we could do very well with height to cover. In this case, we had 30 feet of fill, as I mentioned earlier, but we also started with 14 gauge polymer coated Ultraflow. So you can see here we had a minimum height to cover requirement of 1 foot and a maximum height to requirement 56 foot. So we fit well within the job site parameters. So once the project was bid and the contractor was selected, the contractor went through, and I'm going to take you from left to right on this slide. Basically, we're in that trench, that concrete trench that we showed you earlier from a plan view, and they're aligning the pipe first, and then they're going to make the joint. And this joint, most of the time you see a corrugated metal pipe band, it's going to have bolts, and that increases the OD. So to keep from having to do that, the contractor used the cinch that you see in the middle picture, and then they tack welded the sleeve in place. So that allowed them to have a smaller ID and make the push easier into the pipe. So something new. You can see it's a different material than that of the pipe. In this case, it's more of a construction tool than it is a complete function of the reline itself. It's there to keep grout from entering the joint during the grouting process. So there are many ways to install or slip line a culvert or a outlet as we have here. The contractor from this end was pretty limited. If you remember from the plan views, we had an inlet end which would not allow any type of slip lining or access. So from this case, they had to push from the outlet end. We used 5 40-foot long pieces and 1 20-foot long piece to have a total of 220 feet. And we were able to use a standard excavating equipment. So this video I'm going to show you, it shows them just pushing that next 40-foot piece into place. So if you can imagine, they already pushed a 40-foot piece in, and now they're pushing this. They made the joint, and now they're pushing this piece into place. So at one point, they're going to end up pushing the entire length of 220 feet. So you can imagine with this standard piece of excavating equipment, they're just pushing on the low stream end, and they're pushing that all the way up through the existing structure. A lot of times, I mentioned we're using 40-foot sticks and a 20-foot stick. If this pipe was misaligned or damaged in any further way, we may have been forced to use smaller sticks. But obviously, from an economic standpoint, when we can use longer sticks, it's going to cost the job less. So it's going to be more economical. I will mention that from a grouting perspective, we get a lot of questions. What type of grout mix is needed here? And it's hard for a company when we're trying to show you what type of grout mix to use. We've got more of a national approach, and it's hard to go to an existing supplier and say, okay, here's what we need. So instead, we just look at guidelines. And in most cases, local grout suppliers are going to already have a mix that is approved by the DOT or approved by the local municipality that meets the requirements that we lay out. So we don't have a specific mix design because we found it's more methodical for us to just provide simple requirements and for the local grout supplier to find the grout that they have that will meet those. And the ideal from what we look at is, depending on diameter, either 50 PSI compressive strength all the way up to 300 PSI compressive strength. We're not looking for anything that is very structural in terms of compressive strength. What we're really looking for is something that has low unit weight or low density and will really spread. So think of a spread versus a slump, as opposed to, when you're looking at a slump, you're looking at an 11 or a 1-inch slump or something. We're looking at something that's going to have an 11-inch slump. So here you kind of get a good idea of what we're talking about in terms of flowability. And what they're doing here is they're basically taking the grout from the supplier and they're running it through a grate. And that grate is to help stop rocks or clogs from getting into the pumping system, which can create problems with the pumping system and actually increase the pressure that the hose sees as it's going in through the void between the old pipe and the new pipe. So that's something that we like to see quite a bit. And this is also a good detail of really how fluid of a grout that we're looking for in each project. Talking about plans and specifications, we worked with HDR to create a material specification, which was not a sole source specification. It needed to be restricted enough around the diameter and the coating in order to make sure that the owner was getting what they needed, but it was also something that more than one company, such as Contech, could provide. So it had to be tight, but not so tight as to be a sole source spec. And that was very important to basically all 4 of these projects that we're going to talk about today. And we offer that process to everybody on this call. The last video I'm going to show on this case history is really the project finished. It gives you an idea of what polymeric ultraflow is going to look like. You can see where you can get that Manning's end of 0.012, and it also gives you an idea of how we can obtain a 75, 100, or even greater than 100-year design life. This gives you also an idea of how it was important for HDR to kind of fix some of the minor misalignments and put everything more of a straight line. What you see at the invert was a post snowstorm. We're close to the outlet end of the pipe here, and a lot of that just happened to blow right up into the pipe and then it froze. So some of it has melted and gone away, but what you're really seeing is some leaf and debris that got blown up into the pipe and then was iced into place. So this was a successful project. I will say, from the grout perspective, we had some challenges just at the ending part of the grouting. where some of the pressure jacked, but we were able to fix that, or the contractor was able to fix that, and we were able to satisfy HDR and the owner of their new reline pipe. Jill, before I move on to the next project, I believe we have a poll question, do we not?
We do, Ryan. Our first poll question is, how often do you propose trenchless rehabilitation as an option for your client to consider? Frequently. They tell me if they want me to review it, or never. This is new to me. I'll give you some time now to mark your answers. And just a reminder, if you have a question, please type it in the question box, and we will ask them at the end of the presentation. Answers are rolling in. I'll give you a couple more moments. They're rolling in. Couple more moments, and thank you for participating in our first poll of the day. Well, it looks like most of you have voted, so I'll share the results with you. Ryan, it looks like 24% say frequently, 39% say they tell me if they want me to review it, and 37% say never. This is new to me.
Okay, well, good. That's almost a perfect mix between the three. Hopefully this will help you with your customers and also give you some further background in order to continue to do so. So thank you everybody for your support on that. And we'll move on to the next case history, which really is a stone's throw away from the previous one. This is one in South Dakota, Yankton, South Dakota, so the southeast portion of the state. And it was done by South Dakota DOT. This one had multiple projects. A lot of DOTs, what they'll do is they'll assemble a lot of projects in a relatively similar area and then bid them as all as one project in the hopes that it's going to drive down the price of the entire combination of projects. So on this one, we had two different products that we were looking at, A2 liner and Duramax, so different from the previous one. And this was installed in 2020. So starting with the condition assessment, you see on the picture on the left where we had the 24-inch corrugated metal pipe, which had reached its design life and needed either to be replaced or repaired. And the DOT in this case selected to repair it. And this is where the 21-inch A2000 went. The two other pictures, these are pictures of a 96-inch structural plate. And you can see where, again, reaching its design life, especially at the invert, you can see in the picture on the right-hand side, the crown and the sides of the pipe are in great shape. Maybe the invert has seen some better days. So they had decided to reline that as well. So moving into the hydraulics section, hydraulics can be tricky from a design standpoint. When we're looking at a closed system, or what I call a closed system, such as say a sanitary sewer and a storm sewer, everything comes into play. And when I say everything, I mean Manning's end, I mean pipe slope, I mean open area, or so diameter of the pipe. All of these things come into consideration when determining if we're either hindering the hydraulic capacity or if we're improving the hydraulic capacity. When you're looking at culverts like we are on this project, that would be considered outlet flow. So in outlet control, things like Manning's end, things like diameter, things like pipe slope, all of that come into play. Whereas if the pipe is in inlet control, the only thing that matters is the diameter and how the inlet end is treated. So if there's a head wall or if it's just a projecting pipe, all of that goes into consideration. When you are relining a culvert, which is in inlet control, 100% of the time we are reducing the open end area of that structure. So we are also reducing the hydraulic capacity. Now, there are some things that we can do with culverts that are in inlet control to reduce the negative effect, and that is changing what type of inlet we have in that culvert. So instead of leaving it as a projecting end, instead put an end section on it, cut a bevel into the pipe, use a head wall with a bevel in it. There are a lot of things that you can do, and that we could dive into more detail if there is interest in that. With this project, we had the benefit of both culverts being in outlet control. So what we could do is look at how the Manning's end and the diameter of the hose pipe and the liner pipe line up. And in the small diameter, with a Manning's end of using the A2 liner with a Manning's end of 0.009, we were actually going to be improving the existing flow by about 12%. With the larger diameter, because of the Manning's end and the higher Manning's end of a structural plate compared to that of the Duramax, we actually are improving it much more than the 12%, closer to 79%. So this is something that from a hydraulic standpoint, we pay a lot of attention to in the slip lining perspective. Moving on into the structural perspective, I should say that whenever we're talking about slip lining, we consider that all of the products that we're looking at are going to be self-sufficient in terms of structural support. So all of them are direct bury structures, and all of them can handle all the loads being applied to them within the proper minimum maximum heights of cover. That happens about 99% of the time, but there are instances where the height of cover is just too high. So under this one, we were approaching 45 feet of fill, and Duramax actually will check out up to about 43 feet of fill in this diameter. So it would not check out for this as a standalone reline system. But if you're not familiar with flexible pipe, which structural plate is, you get to take advantage of soil arching. So what that is basically reducing the dead load being acted on the pipe after a certain amount of time, and this pipe has been in the ground for quite some time. So what we could do is reduce the dead load factor in these AASHTO LRFD calculations and make it check out. And we were able to do that for 45 feet of fill, but I will caution you, this is something that we need to be brought in together on very frequently and very early when you have deep cover. From a constructability standpoint, we're looking at the picture on the left, we're looking at grout tubes. Those are the ones where you see doubled up, and then more importantly, the grout runners, or the runners for the pipe. What that's doing is elevating the liner pipe so the ribs of the Duramax do not index into the corrugations of the hose pipe. So it's making it easier to push. They're using temporary internal expanding bands. That's to keep the grout from moving through the joints during the grouting process. And then something that the contractor created was an end cap, and you'll see that in this next video. This video, again, you can see them using the equipment to just continue to push this pipe into place. It sounds like some grease could have been used, but other than that, you see them being able to push against that plate that they developed and push that entire 84-inch pipe all the way up through. So diving in a little bit more on the grouting and flotation, there are really three considerations that you can consider when you're looking at holding down the grout or holding down the pipe during the grouting process. In this case, they use jacks. You see that highlighted in green in the calculations at the bottom. But you could also, if water is easy, you could add water into the pipe, or you can add other types of weight. So I've seen contractors use things like jersey barriers to add weight to the pipe to hold it down. The other thing that we look at on this slide is the grout density. In this case, we were looking at 130, which is actually quite dense. We're looking for something closer to the unit density of water itself, because that's going to decrease the buoyant force that's acting on the pipe. The other two items that may not be as readily apparent is pipe slope. The pipe slope, if you can imagine, we have a minimum grout height or a maximum grout height of 12 inches, as we saw in the last calculation. But the pipe is on a slope and it's long. You can imagine if you've got 12 inches of grout at the inlet end, you're going to have closer to 16 to 18 inches of grout at the outlet end, and that's going to float. So to keep that from happening, in many times you're going to need multiple first lifts in order to not float the pipe. And then compressive strength is always something. We already mentioned that on some previous slides, so I won't go into too much more detail there. Moving into the actual grouting on this, you can kind of see they used jacks on 8 inches or 8 foot spacing. Those are just jacks with 3,000 PSI capacity. And then once the pipe's in place, the contractor will build a bulkhead where the grout tubes are coming through it. And you can see on the right-hand pictures, we had cellular concrete. Basically, concrete or grout was delivered to the job site, and then the truck on the right is actually taking that grout and then turning it into a cellular concrete or cellular grout mix, and that's being pumped down to the bulkheads where they're going to pump that grout through. From a plans and specification, again, like the previous project, we had multiple products were approved for each line, but Contech was able to win the day with our Duramax and our A2000. So I think that's going to end my portion of our case history talk. Before I move it on to Andrew, I believe we have another poll question. Is that correct, Jill?
That's right, Ryan. Our second poll question of the day is, which rehabilitation application does the majority of your experience come from? Do you have no experience? This is new to me. Culverts, storm sewer, sanitary sewer, or bridge and crossings? I'll give you some time now to mark your selections. Ryan, we had a question, what is cellular concrete and grout? If you could answer that while people are answering the poll. Okay, looks like most of you are answering the questions. Give you some more time. If you have a question, please type it in the question box.
Yeah, thanks, Jill. And I was answering the question while I was on mute. So I will answer that question. Cellular grout, if you can imagine, basically you're just using air to lighten the grout itself. So it's mixing a grout with air and potentially other admixtures in order to create a less dense grout. So if the grout arrives to the job site at 130 pounds per cubic foot, then that truck is going to turn it into, say, a 40 pound per cubic foot dense material. Hopefully that makes sense.
Thank you, Brian. Looks like most of you have answered the question, so thank you for that. And I'll share the results. Looks like 24% have no experience, 23% say culverts, 22% say storm sewer, 25% say sanitary sewer, and 6% say bridge and crossings.
Pretty even spread there on the pipe side, isn't it?
Yes, it is.
Well, hello everyone. This is Andrew Jenkins, and thank you, Ryan and Jill, for that start to the presentation. I'm going to go ahead and discuss two more projects before we end the session for some questions and answers. For those of you who had joined a little early, there was a video playing. There was a YouTube video that you can go to that was describing this project that I want to talk about next, the Livonia West Commerce City project near Detroit, Michigan. This is these projects are very similar to what Ryan just presented in many aspects, but there's a couple nuances to the next two that I wanted to share. This one is interesting because it's 1,000 feet of 54-inch in a storm sewer that was utilized to reline a failing 66 and 72-inch RCP hose pipe. There were two elbows to negotiate, a 54 degree and a 36 degree, but what was unique is we used 6.5 foot pieces, and I'll explain why in a second. This project was also published at the No Dig show in 2019 with the NASTT. So next slide, please. So this was a job site that was an old General Motors plant, spring and bumper plant. And during the project assessment, it was determined that there was an environmentally hazardous chemical in the groundwater, and that was infiltrating the RCP storm sewer. So that was a big issue for the developer who was going to redevelop this site. So the plant was closed in around, I think it said 2001 or so, and there was a developer looking to redevelop the project. So they needed a reline solution here that would prevent the infiltration of this hazardous material or groundwater, contaminated groundwater. So the material needed to be chemical resistant, but really needed really good joints, water tightness. Early on, they looked at digging, and one of the big problems here is the groundwater. They figured that even doing insertion pits, excavating insertion pits was very problematic as far as economics are concerned. When looking at the hydraulics, one gift here is that the 66 and 72-inch pipe existing storm sewer was actually over-designed for what their needs were for this new development. So that's a key here, and that's why we used 54-inch pipe. So this is all about the groundwater. There was some abrasion in the hose pipe's invert. So we knew that the 54-inch Duramax, which has a 0.012 Mannings in, was going to provide enough hydraulic flow for the current development and its needs. And this was going to be a wet installation, so that's key as we get into this. Next slide, please. Structurally, they did want us to do a PE stamp on this project, and rightfully so. This is a pretty deep storm sewer. It's pretty rare to see a 19-foot deep storm sewer. So they did have structural concerns. Now the RCP was in fairly good shape, other than the joints themselves and abrasion of the invert. But we always look at this as if it's just a direct bury. Duramax has no problem dealing with 19 feet of cover with 54-inch pipe, and we were concerned about the groundwater being above the crown of the existing pipe. So all that was reviewed, and that's something that Contech likes to provide our stakeholders in these projects, and something as complex as this. Next slide, please. So go ahead and play this video. I just wanted to show Duramax being made so you guys can kind of see what the product is. A lot of people aren't familiar with steel reinforced polyethylene. And this is the one slide where we are talking materials and methods, because this project went through design considerations for some time. Again, some of the key influencing factors here is the watertight joints, those two elbows I mentioned earlier, and how to negotiate that in a reline situation, what products could be used. This was considered wet installation, meaning you couldn't dewater the hose pipe completely. It was too cost prohibitive. There is a chemical resistance issue here. It's not just stormwater. We have some contaminated groundwater and those concerns, but they were looking at service life, and they were looking at the structural service life as well, as this thing needs to maintain for many years to come. And then again, the total install cost was really coming into play. Each kind of idea that the engineer was looking at kept running up against a pretty tight budget. So the four options, it began with solid wall polyethylene butt fused. Again, insertion pits created an issue with this solution. They then looked on to cured in place and sprayed applied products. Again, dewatering was not an option, or it was a very expensive option. And both those need a dry interior. So that's when it went on to a segmental or slipline idea, and that's where Duramax was chosen. And it's has a lot to do with the versatility of what this product can bring. Next slide, please. And the key here is that 6.5 or 7 foot long piece of pipe. So on the far east side of the project, there was a catch basin, 9 foot diameter. And the unique part here is we were able to access that by pulling the lid off and drop it in these short segments. Now, normally we tend to try to use as long of a stick as we possibly can ship. It's supposed to economic consideration. So this really did increase the number of joints, but the problem of going that deep from one access point and trying to negotiate these elbows came into play, and it fit quite nice. You can see the two elbows off to the right there on the plan sheet, and that's the other big problem that was discussed early on, is how are we going to negotiate those elbows. Well, we had some kind of luck here with the 66 and 72 inch hose pipe being over designed, allowing us to use a much smaller product for meeting the hydraulic needs and allowing us some room to negotiate inside the pipe itself. Next slide. So one of the very good things with working with metal pipe and steel reinforced plastic is it is very versatile to fabricate with. And so what we did was we went ahead and created a bell and spigot elbow, and then cut it, and then reassembled it with flange connections at the center. You can see on the photo on the right, that's the spigot in the top, that's the bell, the bottom left, and then the flange connection in the middle. I hope that makes sense. And what you're seeing in the below is just the drawing of the spigot on the left and the bell on the right. So this allowed the contractor to go in and negotiate those elbows and get these placed 19 feet below ground. So very unique application. Next slide. Very similar to what Ryan was showing earlier, standard grouting procedures and techniques were utilized. Grouting tubes were placed. Blocking was used as well. Fairly standard, other than it's 19 feet below ground. But it was a very competent contractor doing the installation. Next slide. And as far as the plans and specs, a couple of things were requested. I mean, they knew they had issues with the infiltration, so they wanted to make sure this thing was going to be watertight after it was installed. And there's a lot of concerns when it comes to grouting something this deep into the ground. Grouting pressures, those are all need to be monitored, and we worked with the engineer and the contractor to really spell that out in the specifications. They also asked that they did some sort of monitoring in the pipe itself during the install. What you're seeing here on the right in the video is a gentleman down there with a tape measure, basically just measuring the ovality of the pipe to check as we grout that it's maintaining its shape. There's also methods that are done where people use rubber mallets, and they'll do sounding on the wall to hear if the grout is filling as designed, or the procedures that have been laid out, and verify that there's no void spaces and things like that. Safety is paramount, obviously, in these types of situations. But once the project was done, there was an infiltration inspection requirement, and they did that with TV. Next slide. I think we have a poll question now.
That's right, Andrew. We have one more question for you today. What is your largest consideration when contemplating a slip-lining project? Is it hydraulics, structural capacity, economics, or grouting steps? I'll give you some time now to mark your answers. And just a reminder, please type your question in the question box, and we will answer them at the end of the presentation. I'll give you a couple more moments. The answers are rolling in. I want to give everyone an opportunity to participate. I'll give you a couple more moments. Thank you all for participating. Just a couple more seconds. Okay. Well, Andrew, it looks like 39% say hydraulics, 14% say structural capacity, 43% say economics, and 3% say grouting steps.
Awesome. Thank you, Jill. Thank you, everyone who's participating in those polls. It really helps us. As far as that last project, for those who didn't get to see that video when we first started, if you go to YouTube and type in Livonia and Duramax, it's worth looking at. There's some really good pictures and things like that to showcase that project. The last project we're covering today, I'll go ahead and go through this fairly quickly since we've really covered a lot of this for the other three projects, a lot of the considerations. This one's in Ohio, up near Cleveland, northern Ohio, and it involved a 84-inch reline using Duramax. It was in a metal structure. This is a busy road in a residential area, so it was paramount that they really wanted to do a reline to not have the issues with impeding upon the traffic with the neighbors nearby. So this was done with 5 pieces, each 24 foot long. And the unique part about this project that we want to showcase here is the internal saddles primarily. This was designed by AECOM, and we've done a lot with those guys up there, and this project went very well for us just a couple years ago. So next slide, please. So Cheryl Ann Drive. This was a very old 108-inch structural plate that you can see in the top photo. The black and silver, so to speak, is basically the deterioration of bituminous coating. So it's a very old structure, and you can see the 2 laterals that are there sticking into the pipe. The bottom photo shows the problem that was going on for this project. There was a sinkhole developing off to the side of the road, kind of in and around the sidewalk area. And what you see here is sometime in the past, from 50 years to now, sometime in the past, there was an extension put on, and that extension connection failed. So what you see here is there's plenty to do from the condition assessment as far as getting this project prepared for a slip line. So they're going to go in and clear a clear path for the new material to slide through. That's going to include cutting out those laterals, removing that extension actually, and there was some issues with an inlet head wall as well being deformed. So this had a lot of problems going on with it and was in need of repair for sure. Next slide, please. One of the big concerns here hydraulically wasn't about the slip line. It's always an issue when you're slip line, whether the product you're using is going to meet the needs of the design. But there's also concerns with the abrasion level and hydraulics coming through it and what product would work best. Now, there was other products specified once this went to bid, but when Contech was discussing with the engineer of record, we had a couple different options we could provide. And because of the abrasion level being 4 or potentially being a class 4 per FHWA, which is a severe abrasion, and knowing the flow rates, the Duramax product was chosen. Polyethylene is a very abrasive resistant material. And when we went through and demonstrated some abrasion type of analysis for the engineer, they went with this product. Next slide, please. Structurally, this was pretty much in the wheelhouse of 84-inch Duramax, 13 to 18 foot of cover. Again, we assume a fully deteriorated hose pipe. Next slide, please. And the unique part here, beyond the abrasion rates, was these couple, I think it was 2 or 3 lateral connections. So again, I keep talking about the versatility and ease of fabricating the polyethylene and steel reinforced polyethylene materials. We were able to develop internal saddle connections that would be placed in the field. You can see the example of one of the saddles on the left there. That's it installed, although it's kind of dark in the middle photo, but you can kind of see more on the drawing itself. So this allowed the contractor to slip line the existing structure, locate the locations of those laterals, cut out the portion of the Duramax associated or adjacent to that lateral connection, and then slide those into place. And those were bolted in and then welded, easily welded. So the welding process for polyethylene is really easy, and there's a lot of trained folks out there that can do it. Next slide, please. the steel reinforced polyethylene pipe is very efficiently designed, and you kind of see this in the photo on the left. It's 48 feet of 84 inches, literally driven there by a pickup truck. So the lightweight nature makes this thing easy to install and quick. You can see they're using an insertion tool. This was pulled into place via a winch. Next slide, please. You can kind of see down below, again, they're protecting the end as they winch this and pull it through. Notice the beveled cut here. So after we pull it in and it's grouted, and again, standard techniques and same sorts of grout that Ryan covered earlier in this presentation were utilized on this project. Again, they were blocking it. They used PVC tubing on the invert to help slide it through. And then they did need something that could be cut at the end to match that beveled end treatment, which you can see on the far right there after the job was completed. So from a plans and specifications, and this kind of wraps this project up, there were multiple products utilized. For Contech, we were the most cost-effective solution. They had a lot to do with the lead times as well. The Duramax product can be a very quick lead time type of material. There was PE stamps required. They did have discussions, concerns about UV, and the steel reinforced polyethylene that we use is a pressure rated resin that has plenty of carbon black in it to deal with any sort of UV exposure. The abrasion rates were addressed, and this again required a video inspection after installation. So just a cool job. 120 lineal feet, but those laterals were somewhat problematic for other types of materials, and it was kind of a slick way for Contech to come up with a lateral or internal saddle like we did. So next slide. And this pretty much ends the 4 projects. Just a couple more slides here, and then we can move on to Q&A. There is a lot of resources for Reline. For the 30% I think I saw in the poll that said they're new to this, there's a lot of guidance even in each state. The Maine, Minnesota, and California are represented here, but there's a lot of guidance out there with the DOTs when it comes to culvert relining, other resources as well, other agencies. Next slide, please. And you can actually find a lot of information with the material suppliers themselves. The metal pipe NCSPA has a lot of information, the Plastic Pipe Institute, and the American Concrete Pipe Association. There's a lot of guidance along the lines of rehabilitation, relining, sliplining, etc. Now, if you go visit Contech, next slide, please. ContechES.com. We have a lot of information as well. We have a lot of products that are utilized for rehabilitation. We have a spot on our website just for that. And we also have a Reline design tool. Please take a look at it. It's very helpful. Along with all the other information and your local sales engineer, we're here to help. And we look forward to working with you. Jill, I think we got about 5 or so minutes left to do some questions and answers.
That's right. We have some really great questions. I can't wait to ask you them. Just a reminder, type it in the question box, and I will ask these gentlemen now. Our first question is, in the pictures shown, what are the large screw heads in the top of the pipe?
There were a couple. I'm thinking, Andrew, that the question was about the South Dakota DOT project, because they were the grout ports. So what those are 2-inch grout ports, if my assumption is correct about the question, and they're used in multiple locations depending on what the grout lifts are. We also use them in the 12 o'clock position if we're using bracing, like those jacks we were using in the South Dakota DOT project. That jack will go through that 2-inch grout port and then brace against the existing pipe. So it's something that it's more of a construction tool than anything else, but it's something that the contractor can use. It comes pre-assembled, pre-installed into the pipe. So that's what those are, and then they're closed off when they're done being used.
Yeah, that was on the Duramax pipe. Yep.
Yep.
Thank you. Our next question is, what grouting pressure should be used when grouting the liner pipe?
You want me to take that, Andrew? Or?
Sure. Yeah.
Okay. So the answer, it's a great question, and it's a very important one, because if you don't pay attention to it, you can create some problems with deflection in any pipe. It doesn't matter what type it is. Good rule of thumb is 5 psi or less, but it's really diameter dependent. As the diameters get larger, and product dependent too, as the diameters get larger and depending on the product, it could be limited down to 3 psi or even 2 psi. So work with whatever material supplier that you're having. They're going to have those limitations based on the diameter and the product. But I will say, ideally, what you're doing is you're not pushing grout uphill. You're wanting the grout to be basically entering into the void, basically under gravity flow. So it'll be leaving the grout port, the grout tube, what have you, into an empty space, and then you're not having to worry about grout pressure as much anymore, because you're not trying to push the grout uphill.
Yeah.
Thank you, Ryan.
We do have information on all of our products on that topic, I believe, in our installation guides. I know A2000, like you said, or A2 liner, which is our PVC product, is 5 psi or less. But
Right.
most of that should be located in our installation guidance.
Thank you, Andrew. Our next question is, can Contech's pipe be arched for relining?
Yeah, I can answer that one too.
Go ahead.
Some of it can, some of it cannot. So the A2 liner and the Duramax that you saw in some of the projects we saw today, that cannot. That is limited to round. But the Ultraflow, or even some of our tunnel liner plate or our structural plate, that can be. And to whoever asked that question, sometimes when you're relining an arch or a pipe arch, the best thing to reline that with is another pipe arch, because nothing is going to match those bottom quarter radiuses better than another pipe arch. So that's a good question, and a very good in the design considerations.
Thank you, Ryan. Our next question is, how do we know if a culvert is flowing in inlet control or outlet control?
You go right ahead. You covered it earlier, Ryan.
Well, okay, that's a good question. That, especially with culverts, obviously the importance is just to bring everybody up to speed. Inlet, whichever one governs. Well, let me back up. So what we're looking for is you basically run calculations. So you basically run a calculation, and these are available FHWA, HECRAS, all of these have calculators, so you can determine if it's flowing inlet or outlet control. What you have to do is run a calculation as if it's flowing under outlet control, and run the calculation as if it's flowing in inlet control. And whichever one has the highest headwater is the one that controls. So hopefully that makes sense. There are some simple ways to do it if the culvert is running, but usually if you're looking at running some, doing a design, you want to run the calculations. I don't know, Andrew, you good with that answer?
Yeah, hopefully they know before the project starts, right?
You should know.
Yeah.
Yeah.
So.
Okay, we have time for one final question. How are laterals with smaller diameter pipes addressed?
It's another good one. And Ryan, you definitely add on to this. So typically, I guess it depends on how small of a diameter we're talking about, but there are equipment that's done via kind of like a CTV camera, where it's brought in kind of on a robot, if you will, that goes in and will core a hole that would match where the location is. There's a couple different techniques. I know that most of our offering is kind of in the larger diameter set. We do use A2 liner in sewer installations, and that's how they would have to do that. Brian, you have some additional thoughts on that one?
Yeah, and I think the laterals on the last project you showed in Ohio, I mean, we had the benefit of 84-inch diameter pipe, so it was, you could enter that pipe and then physically cut the hole and add that saddle and bolt it and then weld it into place. So that's the best approach if you can do person entry. If you can't, like Andrew was talking about, if it's smaller diameter, say 40-inch, 48-inch and smaller, it gets a lot more difficult because you can't enter that pipe, or it's more challenging, especially if you're doing it during live flow. So
dig from the outside, yeah.
Yeah, the best way, if you have the capability to just sink a shaft right there, so small shaft to address it from the outside, that's going to be the easiest and the I guess the best way to do it. There are ways that Andrew mentioned you can do it internally, but that's much more challenging. So ideally, if you could just sink those much smaller shafts at those locations, that would be the best way to do it. That's a great question.
Well, thank you, Andrew and Ryan, and thank you everyone for taking time out of your day to participate in today's webinar. If your question was not answered, don't worry. A Contech representative will reach out to you with a response. A survey will appear once we conclude the webinar. Please complete the short survey to receive your PDH credit. A follow-up email will be sent by the end of the day that will include a link with instructions on how to download your PDH certificate. That concludes today's webinar. Thank you again for joining us and have a great day.
Thanks, everybody.
Thank you.